And the next topic that you have to worry about when your software is in production is how you do upgrades and why you need feature flags. So what's the trouble? What makes upgrades challenging in a software as a service world? Basically, because it's software as a service, it's more or less expected to be up all the time. I've talked about availability, response time, and we also saw that in a 3-tier architecture, you have the nice benefit that you can replicate the stateless tiers to serve more users. But that means that when you're upgrading the software, there are multiple copies of the app that need to be updated on different servers at different times. And so there's going to be some moments during the rollout where some servers will have one version and some servers will have another version, unless you take the app down entirely to do the upgrade. And it could be even more complicated if part of the upgrade is you're changing the database schema in some way. And this is particularly a problem if the old code, the code that's running now, would not work when the new schema is deployed, but the new code won't work with the old schema. So you sort of have to upgrade them both at the same time or neither. So how do you do that? And you might imagine a naive way to do it is you take your service offline, if you can afford to do that. You apply the destructive migration. So what does the destructive migration mean? It might mean the data is changed or deleted or transformed in a way that may not be easily reversible. It may include copying some data. It may, moving data between tables or something. But whatever is needed to get the new version of the code to work properly, then you deploy the new version of the code. Hopefully there's no bugs in any of this stuff. And finally, you bring your service back online. And of course, if you can afford to do this, right? If, for example, if your app is only being used, let's say by, a small number of organizations or everyone's in a similar time zone, you can just do this in the middle of the night when nobody's using it. No one will notice it's down. If you can do that, you should do that. That's the simplest thing, because if any step goes wrong, you can just roll everything back, right? Snapshot the database before you do any of this. Heroku has the nice button for rollback to a previous deploy. So if you try it and everything goes badly, you can always back up. But if your app is such that you can't do this because the amount of downtime would be unacceptable, what else can you do? Just to show kind of the difference between how you would do, the naive thing that I just described and how you would really do it with feature flags. Here's a sort of example of a migration that does things the hard way. And here, the example we're going to use is that right now in Rotten Potatoes, there's a moviegoer model. It's got a single field for the user's name, but for a variety of reasons, we need to have a separate field for first name and last name. So you can imagine this is a problem with the code, right? Because all over the place in the code, there are places that refer to moviegoer.name, and now they're going to have to be changed to refer to first name or last name. And in the database, the table is going to have to look different as well. So here's how you would sort of do it by brute force. You add the 2 new columns, and now you just grab all the moviegoers, and for each one, you just set the first and last names to match some simple regular expression to split up the name. We're just going to assume that that's correct. And when you're all done updating every single record, then you remove the old moviegoers column or the old moviegoers name column, and now you're done. By the way, before we go any further, this is the naive solution because depending on how many moviegoers there are, if there's, a couple of 100,000 moviegoers, not only could this take a really long time to do, but what's another reason that this code is actually really bad? And here's a hint. I have put the bad parts in red. Those are the parts in red, if anyone is having difficulty discerning colors. So even if you could take the service down and it takes a long time to do it, what's wrong with this code? The database is going to try to return the entire table. The real problem here is that when I've said all, this is basically going to try to load essentially the entire table into memory, and it will probably fail. So if you were a programmer in this position and you realize, that's a bad idea, what might you think to do a Google search for if you wanted? This is a little debugging and design exercise. If this is your problem, what might you search for in Google to see if there's a better way to do this? What are some keywords that you might use? We don't want to say moviegoer.all because that's going to result in potentially loading the entire table contents into memory. Even if we're just loading the names of all of them, that's still going to be like 1 million names. There's a lot of memory that's being taken up. So what would be an alternative to doing that? I just did a Google search for active record, go through all records in chunks. That was like my exact search string. And basically, and I remember that there was a way to do it, but my first hit was something called find each. And if you go look up find each in the Rails documentation, you'll see that it does exactly that. It loads records a handful at a time, and you can set the threshold for how many, but I think by default it's about 1,000, which is reasonable. So in terms of its behavior, it looks just like iterating through the collection. Like you get to work on them one at a time, But in the background, what it's doing is loading a batch of them at a time as it runs out. So part of the moral of the story here is use Google. Think of some keywords that describe the problem you're trying to solve and just type it in as a question. You'd be amazed how far that gets you. In fact, a lot of the questions that I feel like I end up helping people with, the answer really is, let me Google that for you. Because if you can just think of a few keywords, you'd be surprised how quickly you get to the answer.
So I think there's two things. One, chunks, there's a method called find in batches. I will actually bring up two things on this. One of this is that doing data manipulation in a database migration file is something that should generally be avoided, because the next time you run that migration, you risk having potential changes if your schema changes. The other way to solve this problem is that this is a place where I think we talk about you don't need to know SQL, but knowing some SQL can really save you here as well. Because if you know the right SQL, you can push a lot of this code directly to the database. And databases, you still have to be careful, right? But you could save a lot of time and effort by using Active Record to generate an update SQL query that might be a lot more efficient than passing everything to Ruby, doing some splitting and doing it back and forth. That might not be the case for everything, but that's also one of those things where sometimes knowing when you can push things to an underlying technology like the database, which is really good at making things efficient, gives you transactions and all this kind of stuff, can be a useful option too.
I do want to keep focus on the feature flag thing here, which is the point. So this is just sort of a side, why using Moviegoer all is a bad idea in moving a large amount of data. But what I really want to talk about is what's the right way to do this if it's not acceptable to sort of do it all at once because it's going to take too long. So the way to do this more incrementally is to use what's called a feature flag. And the basic idea behind a feature flag is you're essentially going to have a version of the code that has two different code paths. And the value of the feature flag at any given instant of time determines which of those code paths is going to be followed. So think of the feature flag like a Boolean, and there's going to be a handful of places in the code where if the Boolean is true, you're going to do one thing, and if it's false, you're going to do a different thing. So how does this work? You start by applying the non-destructive parts of the migration. So basically any database schema change that does not remove or irreversibly change data. So in our case, for example, adding the two new columns for first and last name doesn't destroy anything. It just adds two new columns that start out being empty. So that's a non-destructive part of the migration. Then you deploy some code that's protected by the feature flag. So code that has two different code paths. One of them is in place that will work with the old version of the schema. The other one is in place and it'll work with the new version of the schema. And as we'll see, one of the things that you can use that for is as your app is operating normally, you can sort of lazily migrate records from the old schema to the new schema. While the app is running, you flip the value of the feature flag. So now you've got code that has two different paths. The feature flag has one value, and all of a sudden you flip, and now the feature flag has the other value, so you start using the other code path. If things go really badly, you can always flip the feature flag back to its first setting. And at some point, all of the records will have been migrated to the new schema. At that point, you can take out the parts of the code that have the feature flag value for the old version, and now you can finally apply the destructive migration where you're removing old data or changing data in a way that's not reversible. And for the destructive steps, have a plan for undoing it. So backing up the database, making sure you have an easy way to roll back your deployment if the code has a bug, things that we've already seen how to do. So let's actually put these together and show how you would do the non-destructive migration version of this same upgrade. And the first thing is that we need to modify the schema, and we're going to do the non-destructive part first. That's the part where we're going to add these two new columns, which we're going to need. We're also going to add another column, which is a column that tells us for each specific row in the moviegoers table, has that row been migrated to the new data format, the new data schema or not, right? This is really important because, like I said, we're going to end up with code that really has two paths in it, and the path that is taken is going to depend on the value of the feature flag at any given time. Also, we're going to add an index on that column. We're going to talk about indexes next and why they're important for speeding up database operations. But once we've run that migration, now we have our existing, and this is really fast, right? Running a migration that just adds a couple of columns is not a problem. So now, what is our code going to look like? Well, basically, one of the things we have to do is look for all the places in the code that use the old schema and have an alternate code path in there that would work with the new schema, right? So let's take one example. Somewhere in here, we had some calls to moviegoer.where, and in the old schema, they were just looking at the name, in the new schema, those same calls are now going to have to be modified to do a search based on the last name or the first name. So you could take my word for it that the logic in these find statements and the likes, to just take my word for it that that logic is correct. But the important thing here is we're going to set a feature flag and we're just going to call it new name schema. Basically, the feature flag is going to control which code path is used here, right? So basically, if the feature flag is turned on, we're going to look for a new schema, which is any moviegoer whose migrated column is true. Okay? And remember, what's the point of the migrated column? The migrated column tells us if that specific row of the database has been changed from the old to the new format, right? So initially, that column is going to be false for every single record, right? So we'll come back to that in a moment. So that means that initially at time 0, we deploy this new code with the new migration that we just did. It's always going to be the case that the new name schema is going to be falsy. So we're still going to use the old code moviegoer.where, right? So in some sense, we've done nothing, right? We've sort of put in a feature here, but that feature cannot possibly be activated until feature flag's new name schema becomes true. By the way, there are many different gems that let you deal with feature flags. We'll talk about those in a minute. But for now, just imagine that this feature flag's new name schema is like a runtime variable that everybody can see, right? So all we're doing in this if statement is we're basically looking at the value of something that behaves kind of like a global variable. If it's false, we do this thing. If it's true, we do this thing. If it's false, which initially it's always going to be false, then we do this thing, which is just the old original code that we had. Okay, so we do that. What else do we have to add? Well, one of the things we'd like to do is as the app is normally being used, right? Moviegoer records are being read. They're also being updated. New users are being added. So one thing we can do is at the point where a moviegoer is going to be either created or updated, that would be a good time to right at that moment, change that row to the new schema and indicate that it's changed. And remember that the active record lifecycle callbacks let you plug in specific actions to happen at particular points in the lifecycle of an active record model, like at the time it's created or any time that it is updated, anytime the database gets written. So we could use the before save callback in active record to say, every time you save a record, run the update schema function unless that record has already been migrated, right? And remember that the way this works is that it will try to call migrated ? On the record. Migrated is just a column, so it's going to be either true or false. So basically this says, whenever any moviegoer record is about to be saved, whether it's being updated or whether it's being created for the first time, unless the migrated field is already true, which initially it will never be true, then run this update schema operation before you save it. And what does the update schema operation do? It takes the existing name and it just chunks it into the two pieces we need and stores those. So every time a moviegoer record is updated during just regular normal operation, that specific record is going to get migrated to the new schema. Its migrated column is going to become true. And that means that in the future, if that record is the subject of a find operation, then there's the possibility that we'll be able to use the new schema, right? So far, so good, right? So what we're doing is we're incrementally migrating the records. And this is like without running any special code. This is just let the app do its job. And as moviegoers are updated, they're going to be migrated to the new schema. Now, of course, you can supplement, we're going to call this sort of a lazy migration because the only time we migrate a moviegoer is when they're about to get updated. But we can also, in the background, have some other script that is sort of in batches migrating moviegoers one at a time. So this doesn't have to be the only code path to do it, but it's a convenient place to put the code path. Okay, so now comes the magic moment. Now we turn on the feature flag. The sort of brute force way to do this is you log into something like your Heroku console and you just set the variable to a different value. It's probably better in practice to have a script that does this so that you can back out the change really easily. But the important point here is you do this while the application is running, right? So at no time here have we brought down the application. The application's been up the whole time, but in the middle of the application running, we're going to flip the value of the feature flag. And that means that now the new code path has been activated, right? So remember, the new code path is able to look at a particular record, and depending on whether that record has been migrated or not, it will use the correct form of find where. And essentially, that's going to start the process of from now on, every time we touch a new record, it gets updated to the new schema, etc. If we turn on the feature flag and something starts to go horribly wrong, we could just turn off the feature flag and go back to essentially running only the code we had previously. right? So this is sort of a safe way to do a little test of something, but still have a way to back out of it if things don't go the way you expect. Where would you store the value of a feature flag? What are good places that you can store this value? Database table, thumbs up or thumbs down. And by that, I mean, it could either be a new table or it could be a new column or something in an existing table. But in general, is the database potentially a good place to store a feature flag value? Let's compare with the other options. What about a configuration file? Like one of those various YAML files that the app looks at when it starts up. Why is a config file not a good place? It's not easy to change on the fly. The whole point of the feature flag is you need to be able to quickly change its value while the app is running, but the config files usually are only read when the app starts. So you'd have to stop and restart the app every time you did it. What about a constant in the code? What is the key sort of most important defining feature of a constant? It's constant. That's why they're called constants. And yet we're talking about changing the value back and forth on the fly. So the database table is actually a pretty good place to do this, because the database, as soon as you change something on the database table, anytime the variable is accessed, you can read the new value from the database. Okay, it's not the only way to do it, but in apps that are set up like the way these are for software as a service, it's pretty standard. So that's sort of the first part. What have we done so far? We have 2 code paths in place, and as soon as we flip the feature flag, the second code path becomes active and starts transitioning one at a time as they're updated, those moviegoer records. Maybe we're running that in conjunction with a script that runs in the background every once in a while when things aren't very busy. And so in the fullness of time, more and more of those records are going to be migrated to the new schema, and there will come a time when that migrated column is new, has a true value for all the records. So let's move on from there.